Hey Sandeep, good morning.
There's some background noise.
Sandeep, can you hear me?
Yeah, I can hear you. There's some background noise. Okay, now it's better.
Is it better now?
Yeah, yeah,
Okay. Do you hear any fan noise or something?
yeah. There is a fan noise.
Okay, hope it's better now.
Yeah. There is no AC on.
No, I mean I just came in early. It's a Saturday, right? Like I mean, they're really switching it on. I think by now I think they would have switched it on.
Okay.
So,
Sure. Hey, good morning.
Good morning.
morning, folks. Let's get started. Yeah, feel free to turn on your cameras if you'd like to. Okay, so let's start with any questions you may have, any thoughts you may have from yesterday. Okay, then we'll get started. I think we were 24 people when we.
Sandeep, like, will a quick recap of like what we did yesterday, will that help? Just thinking
Yeah,
back.
we'll kind of do that. Yes, sure. So I was thinking of those two options which we are talking about, right? We'll take a look at those options to start with. So yesterday, I think the way we started a day is we got introduced to domain events, right? As a one-up way of looking at system and domain events. The important thing with domain events is who can create or who can raise domain event is your domain package itself, right? Something in domain package can authoritatively say that item was added to cart, item was removed from a cart, or cart was checked out. It cannot be application service or it cannot be something else. So it is a domain package, and specifically entities and domain services can create these domain events or generate these domain events. We also talked about domain events are not easy thing, right? One second, I'm going to switch on a fan. So domain events are not easy thing basically. We know that. So unless we have strong reasons on why we are using domain events as a communication mechanism, or why we are designing event-driven system, we should have enough justification for that. Otherwise, we'll be maintaining a code, we'll be spending efforts to maintain event-driven architecture. So we were working at one of a client where they had a microservice architecture, and it was on REST API, right? Like service A would call service B would call service C. So it was a modern architecture, right? You can already see it's a microservices and it's a modern architecture. I can't name client and I can't really want to talk about domain also, but there was a high volume there. And what used to happen is when service C was slow for some reason, it was affecting entire chain, right? Because A is calling B, B is calling C. So even though it is a microservice architecture, there was a dependency that everyone is highly available. Every microservice is highly available. And that created a lot of problems because it wasn't just A, B, C. Sometimes the chain was up to five microservices, and you can only imagine what happens if one service is down. Basically, maybe important part of a system are down itself because of some other service. And that's why we kind of chose to the event-driven architecture. And in that context, we use Axon framework and we use domain-driven design because Axon framework is heavily influenced by domain-driven design. It talks about DDD aggregates. If you want to design something, it would talk about DDD aggregates first. So you have to identify domain-driven design aggregates. It would talk about domain events, how to test them. It would give you all the framework code to generate events from aggregate all domain services. So it is highly influenced by domain-driven design, and it follows that philosophy. And now with that, what happened is each service is now independent, right? Because they're not calling each other directly. Like customer service would create some domain event, and then account service would, and it wouldn't know, customer service wouldn't know who is consumer, who are all consumers of that domain event. Maybe account service would consume it or some other service would consume it and act on it on their own schedule and own time, right? So you can see that there is no dependency between services. And that's why we chose event-driven architecture. Developing it, maintaining it was costly, and that's why I'm saying that domain events probably is a solution which you should look at only when you need like a high scalability and HTTP or JRPC or say gRPC and other mechanisms of communication between microservices do not work, or they are not scaling to your requirements. Then we kind of moved on to the cart. Cart has a behavior, so it has a life cycle in the sense that you can check out a cart, you can add items and remove items from cart. Like I may add something to cart and go away and come back after 2-3 days, right? So cart is still in progress in that case, it's not checked out. So there is a life cycle. Anytime you see that object has a life cycle or state machine, there are good chances that that object is an entity. And the additional and a must have criteria for entity is it should have identifier. And that identifier should have significance from a domain perspective. Like domain people should be saying, oh, I need to identify one card from another card. That's the biggest hint for you that it might be an entity. Then we looked at a value object, and the example was money or price. If your 100 rupees note, you can never ever change it to 101 rupees. It would stay 100 rupees, right? And that's why most of the times value objects would be immutable. If I have to give 100 rupees to someone, if I have two notes of 100 rupees, both of them are in good condition, the next person doesn't care which note they take, right? That's why it's a value. But if I take those two notes, 100 rupee notes, to a bank, cashier is going to, for cashier or for bank, it's an entity because they are going to look at serial numbers written on both 100 rupees note. They are going to verify it's not a fake note and so many things, right? So for them, so the object may behave like an entity at one place and it may behave like a value object at other place. Or you may not care about identity of a particular object. Like a classical example of that would be, I have Apple Pencil. When I am marketing it, the marketing department doesn't care if there are 10 Apple pencils of same make and model. They care about just marketing it, right? Whereas inventory cares about those 10 pieces, what's a unique number on them, right? Shipping needs to know what exactly they are going to ship, which one of these Apple pencils they are going to ship. So it would vary as the domain changes. Then we saw a very interesting thing with the example of a fund transfer, right? A fund transfer is something which you cannot put on an account because the behavior doesn't belong to account. Anytime your domain experts are talking about some business process, that's a hint for you that I can't fit this on an entity, this behavior on value object. There is a domain service in a picture. Put a domain service inside the domain package. Like from entity or value object, you wouldn't call database or wouldn't call any microservice. I would keep it same for all things under domain package. That way, domain service, you should not dependency inject or you should not call anything external, preferably. If a domain service needs some data, then let application service or adapter fetch it from somewhere, right? Adapter or application service may call like a another microservice. It may call repository, database to repository. But the point is basically try to keep domain layer away from any direct call to file system, databases, externals, and then unit testing. If you are classist, then unit testing would be easy because you don't need any mocks. Then we talked about how we can take these four things and just start with one microservice. You don't have to start big, right? Look at your one of a microservice. First of all, like temporarily take out controller, repository, and application service packages. See if you have domain package which is rich enough. If it is not, then you have leaked domain logic somewhere else. Maybe probably lot of domain logic is in application services. So start moving that into domain package. And draw a diagram. Maybe you don't have to start moving directly, but draw a diagram thinking this is how it would be. Take that diagram to your business analyst and tell them this is how it looks like, and talk about objects and classes there and see if it makes sense to them. And that's how you can do DDD refactorings with just these four patterns, right? Even domain event is optional, but with entity, value object, and domain service, you could easily refactor your existing service. Application service and domain services are different. Application service basically is all about the transactionality, like add direct transaction, starting transaction, all cross-functional requirement. Anytime you think that this is a domain logic, and if it is an application service, you have to consider moving it either to a domain service, entity, or value object. That's the thumb rule you could try to follow. After that, we looked at we switched the domain and we looked at bank and bank domain, right? There is a customer and customer has multiple accounts. And the business rule there is when I change customer's address, then I have to make sure that all their addresses of their accounts are also changed. That's the business rule. And we saw a very simple example how to solve it without domain service. And we roughly said whenever, I think after that we said that we looked into concept of aggregate, right? Because customer as an entity was managing the account entity. Customer as an entity was also managing address is also maintaining its own address. And that way it was kind of defining a boundary, saying that as a customer object, I am going to maintain all account object which belong to me and all address object belong to me. That's the concept of a boundary. And it says that I'll make sure any method which is called on myself would be always follow the business rule and would be always highly consistent. And that's where that concept of atomicity and consistency kicks in, because how do we ensure that when a memory things die, when process dies, on a disk I have things in consistent way, written in a consistent way, so that when I recover them back into aggregate or reload them back into aggregate, they are consistent. And that's why we take help of database transaction, relational database transaction with specifically with or any, even NoSQL supports the ACID properties these days. So any transaction which supports ACID properties. And we talked about two things, right? Once you identify aggregate or you identify a domain service, both of them potentially may become microservice. That's a rough guideline, right? It may not be always true. You may have a microservice with two aggregates, even though very uncommon in my opinion. But you'll find opinions on that from people. If you read Life Beyond Distributed Transaction, you would probably fall in a school of thought that one microservice is equal to one aggregate. The whole reason, so let me try to explain this. This is a so take an example of I think, yeah, before I go there, let me switch back to the customer and account example. Remember what happened yesterday when towards the end of day, we have a customer as an aggregate, so we have microservice, and account is happily acting as an entity in that domain. And we have one microservice, so one database, and we have two database tables, right? One of, one second. One open database table is basically a customer, and another database table is account. And our transaction to update customer address and account address is happening in one database transaction, right? Because the customer aggregate it's aggregate, so it has to be, things within an aggregate have to be always atomic, consistent, and we guarantee that, right? And that's why it's taking help of that database transaction. Now what happened is, over a period of time, like if you are e-commerce like Amazon or anyone, over a period of time, your number of customers would grow, your number of orders would grow, number of products would grow, everything would keep growing and it wouldn't fit in a database, right? In one database, basically. So this is what happened in yesterday's cooked up situation. We have billions of record in customer table and billions of record in account table. Now Postgres was slowing down because of, let's say, large volume of this data. So the solution which we came up with is to split the things, right? And split the things in a sense that customer microservice or customer aggregate kind of says that I cannot now take care of account because that's slowing me down. So it says bye-bye to account. Now there's an account as an entity, and because customer has given up on address updation of account itself would have to do that. So it becomes a responsibility of account now. So then account starts saying, oh, okay, looks like I am going to be an aggregate now because I'm maintaining my own address, and maybe there's some other attributes, KYC and whatnot in real life. And in our example, account become a microservice because it's become a aggregate, and our rough guideline came into picture. So, and now things are easy, right? Things are eventually consistent. The business rule is still followed, but it happens with delay of certain time, right? Because what happens in customer microservice, you have customer table. So that transaction gets committed saying customer address updated. That's the only thing customer microservice does. And it publishes a domain event saying customer address updated. So maybe I'll share the code now just to show it while I'm talking about it. Right, so I'm going to open customer only microservice because now things have changed. So the first thing you should notice here, we do not have account class here, right? Because account is its own aggregate, and aggregate should not refer to another aggregate directly because you don't have that class here, so you can't also. And I'll come to that. There is a very interesting point there. Why account one aggregate should not refer to another aggregate directly. So you see how customer class has changed now. It is now not dealing with account class because there isn't account class. It's dealing with just account IDs. It needs to still know which are the account IDs I am concerned about. If you see update address method, the way update address method would change is that code which we had to update account address, that's gone. And now it's going to raise this domain event. We have list of domain events here. It can be pushed into this base class also. So it's there in this base class, list of domain events, and there is a get domain events and clear domain events method. But I just copied it for understanding purposes. So what we're doing, we're creating this domain event, and we're saying, oh, by the way, the domain event is customer address updated event, and this is inside the events, and it is telling for which customer ID it was updated and what are the new address data, right? That's what you don't want to use again domain classes directly inside your event, because events are going to traverse outside your microservice, and you don't want, when you change a domain and if you put address here, this domain event would also get changed when you change a domain value object. So you have to decouple them, and you have to create a copies of the data and keep them as primitive as possible. And that's where it ends, right? This customer aggregate is done, right? Basically it generated domain event, and that's it. Now if we look at what happens in our app service to handle this, is I'll follow the flow from controller again so that it's clearer. So you come to update address. So we're saying, okay, go ahead and update to new address. Now we are inside the app service, application service, which is here outside the domain package. And what that app service is going to do is this code basically. It's going to find a customer domain object by making a call to repository. So that's the first thing. So it has a customer domain object. Now it's calls customer.update address. That's the second thing. And it updates its own address and it creates this domain event. And this domain event is with customer domain object in this list here. Now we need to do two things, right? First is we need to get this domain event from a customer. So we are getting them customer.get domain events, and we got list of domain events which were generated after update address was done. And then we are using Kafka template. This is all functional code actually. You could check out and install Kafka locally and try things. And then you are sending it to a topic called as customer topic. Now, how do I decide that there is a topic called as customer topic? It's a relatively easy guideline. One topic per aggregate. So you have customer aggregate, so you can do a customer topic. Now, those of who you know Kafka, there's a concept of partitions in a Kafka. And what partition ensures that for a particular key, like a key happens to be customer ID, partition would ensure that events appear in order in which they were created. So for a particular customer, if there are multiple domain events created, then if you are if you are putting an event on Kafka with a key, primary key or key of the event as a customer ID, then you are guaranteed that for that customer, events should be always in order in which they were generated, because you don't want, for example, cart checkout event come first and then after that you got cart update, cart item added event for cart ID 1. You don't want that, right? And to do that, you have to use cart ID as a key of the event. So events are keyed by domain events. When you put them on a Kafka, key them by your primary key. And then once we send it to Kafka, we have to clear domain events because we are done with that, right? So we sent event to Kafka. Now we have to do one more thing. Remember, we need to still save this in a database. We send it to Kafka, this domain event, but we need to update the customer's address in a database. So that's where this customer repository.save comes into picture. Now you can see that we are writing to two different systems, right? One of them is Kafka and another is a database. And we want to ensure both of those things happen or nothing happens. We can't even really start a distributed transaction because one of them is not a database and another is a database. So there's a concept called as transaction outbox pattern. And I'm not going to talk about what transaction outbox is, but transaction outbox pattern would make sure atomicity that both things happen. Event is put on a Kafka and write and update happens to customer table in relational DB. Because if you put something on a Kafka and you fail to write to database, it's a pretty bad shape to be in. You're inconsistent already. World knows address change and you yourself as a microservice do not know in database address change. Or let's say you know yourself, your database call is successful, but you couldn't let world know that address was changed, and then account microservice wouldn't know customer address was changed and it's supposed to update to a new address, right? So really bad things would happen, and that's where the transaction outbox pattern is one of a pattern. There might be multiple would come into picture, right? So that's how the whole thing would happen. And now things are eventually consistent, right? This domain event is put on a customer topic and the name of a domain event is customer address update. Now let's look at how account microservice looks like. So it's the same thing, right? The most important thing, as I keep repeating, is a domain package. Other things are secondary. So the first thing is we have domain package here, and remember the account has now become an aggregate. So account class was moved from customer microservice and it was put into the account microservice. This is account microservice. There is a UUID and there is address, right? And now this method is public, no longer protected, and so on and so forth. Now, we'll have typically similar layers here, right? There would be a repository, there would be an account controller, and so on and so forth. And then there would be an account application service. Now, this is a place, application service is a place where it's subscribing to that domain event, customer address updated event. And the name of a topic is, I think this topic name is customer topics or something like that. And it's listening to that topic, and whenever it sees that it receives that event, reads that event from a Kafka topic, this topic, we are inside the application service of our account microservices listening to this event. It's going to load the corresponding account for that customer ID from the database. It may have multiple of them, and then it's going to update the address to a new address which came in an event, and then it's going to say repository.save transaction, right? It's going to save that in a database, and that's how the whole flow would finish here. And this may happen with some delay, and that's why it's a eventual consistency, and business people should be okay that a best case scenario, it may be few seconds or few seconds, but in worst case scenario, say this service went down, account service went down, then when it comes back up, then it's going to listen to that event and then update the account address. So there are chances that there would be a substantial delay. Now, if address updation fails here in account microservice, then account would have to raise a domain event saying that customer address updation failed, right? Or account address updation failed. That domain event would be listened by customer microservice, and it would roll back its earlier thing, right? So it had updated and committed to a new customer address. Now it would change back to the old address. So it's like when something fails here, you have to raise a compensating domain event. So you can see the complexities of maintaining this system, right? Like it's not one way, it's all over the place. Like customers microservice event was listened by account microservice. Then if something failed, account microservice is going to create a domain event. Now that needs to be listened by customer microservice, and then roll back undo what it was doing, what it has done already, and then commit a transaction with previous address. So lot of things to take care of, lot of nuances to take care of. And why I was saying that argument about like if you accidentally, or say that as a team you said that let's put two aggregates in one microservice. For a moment, let's say you folks did that, right? Now, as those two aggregates keep on increasing, like let's say in our case, cart and order were those aggregates. Those are the two aggregates you have put in one microservice. Now you start saving cart and order, one cart and its own order, corresponding order in a database, or sometimes you may have multiple orders, right? Based upon who is shipper and all that, who is a supplier and all that. Now what would happen is your transaction boundary is becoming larger. And one way to explain that is, say that when you started, you're storing cart and order in one transaction in database, and you had millions of records, and you were fine with that. Now, over a period of time, your record count started increasing. Now you have to shard the data. What happens when you shard the data? You were on one physical machine. When you shard, you may have to put that data in another machine, right? So it may happen that you have a card and you have corresponding order related to that card. They may not even reside in one node of a database cluster. One may be on node 1 and another corresponding order may be on node 2. Now imagine you earlier used to do a transaction because it was all sitting in one node and you're happily doing an ACID transaction. Now imagine you're suddenly talking about distributed transaction. And imagine a situation like you're using a MongoDB before version 4.0 or 3, I think 4.0 if I remember that correctly. MongoDB did not support transaction across two tables, which is called as collections in MongoDB. That means you're kind of screwed now, in the sense that you have no way of achieving that consistency because cart collection and pre-Mongo 4.0 and order collection, there's no way to guarantee the ACID transaction because database doesn't support it. And if database doesn't support, you can't handwrite it actually. And that's where the rule of thumb, even though MongoDB 4.0 supports distributed transaction now across collections, not encouraged to do that, but it does support. And that's the whole thing, right? Anytime you put two aggregates and you put a team discipline that don't do a transaction, don't save two aggregates in a one transaction, one developer, a new developer or someone would come and accidentally start putting the two aggregates in one transaction, and that would cause you a lot of pain later. And to avoid that pain, the general guideline is one aggregate is equal to one microservice. And that's why if you read a DDD literature, it says aggregate should not refer, like customer aggregate should not contain list of account aggregates. If account happens to be aggregate, if it is entity, that's fine, because you will run into all these issues. And best way to understand this would be reading Life Beyond Distributed Transaction, the paper I told you yesterday. It explains this in much better way than I can. So do read this paper. Yes, please go ahead.
Yeah, I mean, I'm not sure if you covered this point. You were speaking about the outbox pattern, right? I mean, even with outbox, if you read through it, right, you'll understand that there are some challenges with outbox. One another way, I mean, it's about you sending a domain event out to a queue. Simultaneously, it also update a database. There are two systems in the background, right? When you read it, you will probably get to understand that. So the challenges are your write to the DB might succeed, but your post to the event queue might fail. The post to the queue might succeed, but the write to the DB might fail. So all of these things typically happen, the failure mechanism. So one another way of handling that is listening to your own events. Basically, you raise an event, that event gets posted. If you are unable to post, you keep retrying. You listen to the same event that was posted by you and take that and process and update the DB. And the other listeners who are interested in the event as well will take the event and process it. So that way, it will give you a more robust solution compared to your outbox. Again, there are multiple layers here. First, you need to understand what Sandeep said, then read outbox pattern, and then read this listening to your own events pattern. So you will get to connect the dots, right? By the way, it is very silent. Can we have more interaction, please, people? I know it's a Saturday weekend morning.
Yeah, I think that's a good point, Srihari. Yeah, I think it's interesting. If you have any references of some material on that, that would be good for people to kind of read on.
Sure, I'll see if I can pull the blog post that explain this one. I'll see if I can pull it out.
Cool, that's nice. Yeah, Saiteja, please go ahead.
Yeah, so I have a question with what you said about aggregate should have like one microservice, one aggregate, one microservice, right? So, like we can take the example of cart itself, right? Like what, until what level can we extend this, right? Because let's say we moved out like account and customer into separate microservices. But let's take the example of cart itself. So cart and order we have separated, let's say. But in cart we still have like, you know, the price and the product. Let's suppose there is a functionality that you have to apply like a 50% off a promo on all the products.
Yeah.
Or the products in the cart. Then again it's the same thing, right? Cart becomes an aggregate, and then there is like you have to update the discounted price in all of them, and we are back to the same problem again. Like so, a domain will have like many subdomains, and sometimes it has
I think the problem though, what problem you are seeing with updating a discount based upon a discount, updating the cart, applying various discounts, like what could go wrong there? Like why would you have to split it further? That's the question you'll have to ask yourself. Like what is the reason in your use case, like applying multiple discount, that's okay, right? We can do that logic, or maybe answer comes from some other microservice that give me discount for this.
Yeah, so it could be anything. Like just giving an example. Let's say a
Yeah.
functionality there where you have to apply.
Yeah. Yeah, the first rule is keep as coarse grain as possible. Don't split. That's the simplest rule you would hear in DDD community. Split only when it is needed. I think, I don't know this is whether it's true, but people say that it's difficult to join things back, easy to split things. Like if you're a bigger aggregate, easy to split. But if you're two aggregates and you're joining them back, then it's more work, is what I have heard generally. But to answer your question, I think Saiteja, delay it as much as possible. If there is a business reason, like say you split something and business came and say no, why there is a delay? I want both of these things to be immediately in a correct position or correct place at same time. Then you know that these two probably aren't aggregate. It should be just one aggregate, because business looks at both of them they always want them to be consistent and always updated, and that means that's a hint for you have to merge two aggregates. Like splitting aggregates, it can happen for two reasons. One is a technical thing which we just talked about, customer and account, and it could be you kept on adding new functionality and such that the aggregate become too big to manage, and that's where you saw that in terms of developers who were spending time on it, or in terms of just sheer maintenance of it, you would start thinking about, can I split it? And then you will have to see, when you split, it's a eventual consistency. Is business okay with eventual consistency? That's something which you'll have to confirm with them.
Yeah, but there is also a trade-off between okay, would I want to have like easy manageable smaller microservices, or do I want a lot of communication between them? Sometimes
Yeah.
there'll be a lot of interdependency between them, like updating here and updating there at the same time. Then
Yeah, like them co-screen is what I would say, Saiteja. Don't make them smaller, right? And that's where like aggregates and domain services are good starting points in my mind for this. If you want to put multiple aggregates in a microservice, then question yourself, like what are implications of this? What would be the problems with this? What happens if people do transactions, one asset transaction across both of them? When scaling, when these scales. So you ask those questions, and then that would help take decision. Because you would find people in community, DDD community, and generally microservices world, people talking about multiple aggregate in one microservice. But if I have to go by Pat Helen's paper on life beyond distributed transaction, I would rather fall in one aggregate is equal to one microservice camp. And that's what I right now my opinions are, because I put two, I'm already giving a chance for someone to make a mistake, that they start saying two aggregates in one database transaction. But yeah, happy to discuss, Saiteja, if we can get on a call later and any real life example you have, and we can look at what aggregates are there, and
yeah, I'll get in touch with you offline someday.
yeah, sure. Cool. Thanks. Any other thoughts, folks? We have one less people than yesterday, so I think we are good. When we left, when we stopped yesterday, 24 were there. Oh, I know. I think someone pinged. They were not feeling well. Who was that? Yeah, I think someone was not feeling well. They left around 3 o'clock yesterday. Okay, cool. Any other thoughts, folks? Yeah, Meghna, please go ahead.
Yeah, so I had a question like Srinari's also said that listening to your own events can become